Are we live? Just want to know. I think we are. That's awesome. Let me just update the title. This is not the title. So, yeah, I actually wanna. Man, this is not. It's so outdated title. This live stream will be about. Mm, so I have some topics that I want to cover, and we're gonna be seeing if we could get most of them done. So Terraform, um, understanding. Let's say understanding Terraform, Docker, Kubernetes, and then we have bash scripting and AWS Cloud Practitioner. Practitioner. Prac C-T-I-O-N-E-R. Prac. Sorry about that. Let me see. Practitioner. Practitioner. Okay. T-I-C-T-I-O. T-I-C. No. Prac. T-I. T-I. Okay. T-I-T-I-O-N-E-R. Practitioner, a person who works in a specific profession. For example, a doctor or a nurse is a healthcare practitioner, right? So yeah, so I kind of want to go over this in this live stream. I know that this live stream is a little like all of a sudden, but let's try to get that done. Also, this description is pretty outdated, so let me just go to my YouTube studio.youtube.com. And what I want to see is that we have to go to the settings, and we got to go to the upload defaults. Yeah, and I would prefer changing the defaults to this instead. Okay, now package.json is just too outdated, so I would just say getting started or something for the timestamp. And you could just copy for this. For now, let me just copy the whole thing. Yeah, let me just copy from here. Just copy this. Okay. And yeah, you can apply for this. Save. And for this description, we're not talking about any kind of data science. So I'll just replace it with all of this. Oh yeah, and just wanted to say, if you guys want to check out some nice gear, things that I recommend for a gaming setup or PC, then these are some Amazon links. So try them out. They're going to be in the description once I apply save. So just when I click on save, you'll see them. They're going to be in the description. Right now, this is just a bar and chart. And yeah, so we're going to be studying about, Terraform and Docker and all these other things, but we're going to be using AI to learn, and let's see how much we could go. So let's say I am a complete beginner in Terraform. Explain what it is and also provide an exercise which let me emphasize CIS, which I can do on my Windows computer. Okay, I'm just gonna say it like that. And look, exercise spelling is also wrong. It doesn't really matter, but you understand the goals here. So Terraform is an infrastructure as code tool designed by HashiCorp that lets you define and provision infrastructure using simple declarative language instead of manually setting up servers, databases, and networking resources through a provider's console, like AWS, Azure, or Google Cloud. You write a configuration files to describe the desired state of your infrastructure. When you run Terraform, it reads these files, connects to your provider, and then creates or modifies resources accordingly, helping you manage complex infrastructure with minimal human error. So this is so simple. I'll tell you what's happening here. providers are basically Terraform works with various providers like AWS, Azure, Google Cloud, and others, each offering different services. You use providers to interact with these services. Resources, these are elements of your infrastructure such as servers, databases, and networks defined in configuration files. State. Terraform keeps a record state of your infrastructure's current configuration, allowing you to manage changes and track the resources it created. Modules, reusable chunks of configuration that help you organize your code by grouping similar resources or settings. Plan and apply. With the plan command, Terraform shows what changes it will make. Apply actually makes these changes. Now, deploy an AWS EC2 instance with Terraform. This is one classical example. And what I'm going to be saying is that Terraform is basically an infrastructure as code tool. And you could use this as it's just like a language. It uses the HCL programming language. So you define infrastructure and you write a script of it. And then you just run it, and then it would provision or basically supply that infrastructure. And the common providers like AWS, Google Cloud, right? All of these they have a link with Terraform, and then you could provision and destroy architecture or infrastructure without any human errors. So install Terraform. Download the Terraform installer for Windows. This is going to take time. So let me just see if I could Terraform install for Windows. We just want to quickly go over things. I don't want to like waste too much time. So over here you can see that there's a Mac OS version. Sorry. So we have a brew tap, HashiCorp tap, and we have so this is for Mac OS. I don't have Mac, so I'm gonna use the binary download, which is the AMD 64 is for that, but mine is 386 version, so I'm gonna download this one. I'm gonna go into my downloads folder and make sure it's downloaded here. After that, we're gonna go extract it and add the folder path to your system's path variable to use Terraform from any command line. Install AWS CLI. Now click on this one. It would take you to the AWS CLI version. It's going to show you which one you want, which is Windows. And over here, we'd say that we support the AWS CLI on Microsoft supported versions of 64-bit Windows, and the admin rights to install software. And after that, install or update the AWS CLI. So to download the AWS CLI, download and run the AWS CLI MSI installer for Windows, which is this one. Alternatively, okay, so I'm just going to run this as well. Alternatively, you can run this command to run the MSI installer. So this is a command to run the MSI installer. For various parameters that can be used with MSI exec, see MSI exec on the Microsoft Docs website. For example, you can use the /qn flag for a silent installation. Okay, so this is another, like there's a flag here at the bottom for just silent installation. After that, you could just check if you have AWS installed or not using that. Yeah. So what I'm going to be doing is I'm going to go to the downloads progress and see, but both of them are installed. Go to this one and extract Terraform from here. So this one, what I would say is, go here and then Terraform extract over here. So extract. So you basically say extract all or open. I normally do extract all, and then show extracted files when complete. I don't check that out, and it should extract it within the same space. Okay, you have Terraform here, and then there's the Terraform executable. Now what I do is I actually you get this, and I normally don't put the Windows 386 over here. You could just leave it till this 1.9.7. This is the version of Terraform. And what we have to do is actually we have to cut this folder, and you could put it in any folder you want. Normally what I do is I put it in the C drive. So I'm going to go to the this PC. I'm going to go in a new window, and over here I'm going to go to C drive, and I'm just going to paste it right here. Okay, so now I have this Terraform 1.97. I'll just copy this. I go to my environment variables. Okay, and now one thing you have to notice here is that if you go in environment variables, you have edit environment variables for your account and edit your system environment variables. Go in system environment variables, and over here you go to your environment variables here, startup and recovery, and then from here we'll have user environment variables for administrator and system variables. Normally what I would do is I would go with system because it would go for the whole entire computer instead of just one user account, right? So that's only recommended if this is your own computer. So I would recommend doing this. Now go to the path and then edit here. And over here you could create a new and then paste in Terraform. Interesting that I see Terraform already incorporated here. That's crazy. I mean, that seems like okay if I press OK and OK and OK. I feel like I already had Terraform installed. Oh wow, I did this back in 8. So that's October. I did it way before, and I already have it. Like I did it multiple times. Um, so let's see what happens. So what I'm gonna do is I'm gonna go in environment variables again. I'm gonna remove those other ones so that it does not create any issues. Environment variables. Go to the path. Edit. So this one. Just I also have Amazon EC2 as well. So I'm gonna remove this. So you can see over here this one Terraform. You can just delete it from here. Okay. Then this is the one that we have. Let's look at this path. I wanna double check where this exactly consists of. So this is the Amazon program file. So I think it's like the same thing if you go back to the MSI installer. Click on this. It looks like AWS CLI. Yeah, V2. Welcome to the AWS command line interface. V2 setup wizard. Please wait while the setup wizard prepares to guide you through the installation, computing space requirements. It's taking some time, but yeah. This one is also AWS V2. So what it means is that I already have them installed. I don't need to do the setup process because that's just going to waste extra time. But if I go to the command prompt, cmd, now over here I should type in terraform hyphen version, and this should give me the version of my 1.9.7 whatever Terraform is. Let's see if it actually gives us or not. Um, so no, computer's a little slow. Yeah, so over here it's not gonna go. I'm just gonna cancel this for now. Are you sure you want to cancel AWS command line interface version 2 installation? Yes. And then you could say over here AWS command line interface was interrupted. We'll just say finish. Now you can see over here I do have Terraform v 9.5, 1.9.5. The version of Terraform is out of date. Okay, so it's basically looking at my older version, right? So it seems like we have another Terraform installed as well. So this is going to create problems. So what I'm going to do is there's this 1.9.7 I have, but there seems to be another Terraform installed already. I'm going to go and check where that could be. So there's like Java, JDK, other things like Node.js, things that I've installed in the past. But if I cancel this and I go to the maybe in the user variables and go to the edit here, Heroku, we have bin, npm, also other these things like that. Just cancel this as well. Let's go here, edit. Um, yeah, so Docker I don't understand over here, but this is the Terraform. I think I thought I deleted this. I don't know why it came back. Okay, okay, okay. Let's go back here. Let's go to the program files. Open, copy address, paste in the Windows Explorer, and paste it right here. Or I'll just go here. So this is my other one. Let me go back here in the. So yeah, I feel like we're in the stream still working. So it says drop frames 614. Everything looks good. CPU 60 frames per second. So what we're going to be doing here is we're going to go to the program files. So this PC over here, there should be this Terraform and this one. So let's just delete these. Should have known that earlier. And yeah, so now I think it should be permanently deleted. Exit, run cmd again. Okay, so let's go and write Terraform hyphen version. Okay, now we have the latest version. Okay, 386. We have that. We also have to check the other thing. What we were talking about was AWS. Run AWS configure and enter your AWS credentials. Okay, this is also some extra stuff. I don't know why, but you can go over here and just type in AWS hyphen version, and it will tell you whether you have AWS installed. And because it's in my path, it should say the version of AWS. Just 1 second. Okay, so you can see over here AWS CLI 2.17.36. Okay, so that means we have AWS CLI as well, 2.17.20. Oh, what do we have? 36. We have even the latest version. Python version as well, 3.11.9, and Windows 10, and then we have XZ, AMD 64, and over here too, the same stuff. Okay, XZ, AMD 64, but they have a prompt /off. Okay, so now after that we have this. Let's go back here and it says run AWS configure and enter your AWS credentials. Access key, secret key, region. Okay, create a Terraform configuration files. So we're going to create some Terraform configuration files in a new directory, Terraform demo, create a new file named tf, main.tf, add the following code to main.tf. But before that, we're going to run and enter your AWS credentials. Now, where we can find these AWS credentials, right? This is a question. So, let's go here, and what I would say is let's create a folder. Okay, so I'm gonna create a folder. Let's say within. Where can I put a folder? So I'm gonna create a folder in C drive, and I'm gonna create this folder as let's call it as cloud work. Okay. Within this cloud work folder, I'm going to open this up using Visual Studio Code. So I just did code and space dot. It should open up it in VS Code. After that, I'm going to run the command line within this place. So it just makes it more simpler and easier. So over here, you press Control and backtick. This opens up a command prompt. But before that, just trust this. You have Windows Subsystem for Linux installed on your system. Do you want to install extension for it? You could install these later on, but I don't recommend doing anything right now. This is the terminal. Press Control and backtick. So it's just going to open up my PowerShell. Just to verify, you have Terraform. You have AWS CLI or AWS -- version. Okay, so what you want to do is you want to say the command which was provided here. So it's called AWS configure. AWS configure. If I do that, it says AWS access key ID. I don't know it, right? So where is this? We'll have to go to the AWS account. So let's go to AWS. I'll just say AWS. Okay. Before that, I mean, some people might not know where they could find this. So you could say, oh, I'm new and I don't know where my, and then just say the thing that was required, AWS credentials, right? Okay, no worries. Here's how you can generate AWS credentials and configure them on your system. Now I heard that AWS, I'm not sure if it's free or not, but we could ask it as well. Is it free? I need it free. Come on, we don't have sponsors for this video, so we need it for free at the moment. Okay, AWS offers a free tier with many services available at no cost for the first 12 months, including EC2 instances. And what is EC2 instances? Is Elastic Compute instances. Okay, these are like compute. Like if you want like infrastructure, like like resource, it's called Elastic Compute Cloud. So basically, it's a part of the Amazon's cloud computing platform that allows users to rent virtual computers on which to run their own computer applications. Basically, you're renting computers from Amazon and you're running your applications there. That's what EC2s are. Okay. Sign up for this AWS free tier account. Go to AWS free tier and sign up for your email and address. And I feel like I do have an account. Go to aws.amazon.com, AWS free tier, gain free hands-on experience with AWS product, get a free account. So I believe I do have an account. I'm just gonna log in and see. Yeah, root user, email address, root used for account recovery and some administrative functions, and then AWS user account name. So I think I have one. So let's go back, sign in. So it's asking for an account ID, the IAM username, and the password. Okay. And you can see over here US East -2.signin.aws.amazon.com. So one other thing I want to see is that it's asking me from the AWS Access Key ID. Okay, it's okay, but let's go and find my AWS account. Okay, information. So 1 second. Okay, Amazon AWS account. So account ID. What could be the account IDs? Root user. Okay, I don't even know what my account ID is. IAM username. Okay. 1 second. Let me do another one. Okay, so I have another one. So what I'm gonna do is I'm gonna go to another Chrome profile and log in with that one. Okay. Over here you can see the account ID is this for some reason. So my username is this, account name IAM. Okay, and the password is basically, let's hope this is like correct. Okay, so authentication information is correct. Please try again. Account ID seems like something off. I don't want to waste that much time, honestly. So I'll just sign in using root user email. Okay, there you go. Next. I believe this is AWS. Okay. Second. So I guess this is the root user, right? Yeah. It should have the password matching. Okay, keep your account secure. You could add a multi-factor authentication device name, right? A multi-factor authentication using one of the options below. Now we could have an authenticator app, passkey, security key, or hardware. Right now we're gonna skip. Later we might add. But yeah, it's us-east-1.console.aws.amazon.com/console/home/region. And then we have the region. Okay, so we're back in our dashboard. That's good. Yeah, I used to use this a long time ago. So what I'm gonna be doing is I'm gonna have to I have to provide required information. You'll need to enter some details, including a payment method, credit or debit card for verification. AWS will charge a small amount, like $1, to verify your card, which will be refunded. After that, select the free tier option during setup to ensure you're using eligible services for free for the first 12 months. Now, AWS credentials, access key and secret key. Like, where can we get this? Because we could make some infrastructure here through click, 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 right? We could create an EC2 instance, or we could create a VPC, or we could create an S3 bucket. But how can we do it? I think, yeah. So how can we do this with the Terraform, right? So what we're going to be doing is we're going to get an access key and a secret key. So once your account is set up, you'll need credentials to authenticate Terraform with AWS. Here's how to here's how to basically here's how to generate them. Log into the aws.amazon.com, and I believe we are inside of it. Let's just go aws.amazon.com. It should be log me in because I'm already logged in. Let's see. No, this is just like the main homepage. Okay. You can see also in the website, one interesting is global network of AWS regions. So there's like different regions in the world, and the map shows that there's like Kingdom of Saudi Arabia coming soon, and then there's Tel Aviv, and there's UAE, there's Hyderabad, launched in 2016, Mumbai, and Hyderabad in 2022. So we got some of these, and you can see over here. There's one gonna come soon in Mexico, Sao Paulo, right? So we got a lot of progress. It's honest, but yeah, let's go back to the console dashboard and let's read the instructions. So over here, go to the IAM Identity and Access Management Service by searching for IAM in the console search bar. So you just have to search IAM. Okay, it's called Identity Access Management. Just click on this. Identity and Access Management. In IAM, go to Users and select Add User. So I believe so. We're going to have a create new user, Terraform user with programmatic access. Enables access via access keys. Attach permissions. Attach the EC2 full access policy for this user, which grants full permissions to manage EC2 instances. You can also attach more policies if needed in the future. And then after that, create the user and download the CSV file with your access key ID and a secret access key, or copy them immediately. This is the only time you can see the secret access key. After that, it's just going to be gone. Okay, so let's do that right away. We're going to create a new user right now. Okay, so over here we're going to have security recommendation. Right now it's asking me for multi-factor. Root user has no active access keys. Using access keys attached to an IAM, identity and access management, right? User instead of the root user improves, basically user instead of the root, yeah, improve security. So that's why I'm gonna create a user, and I believe should be a button over here, user groups and users. Click on this, and you can see I have no users for now. What I would do is I would create a user here, and let's just give it the name as what it's required. Like it just said user Terraform comment hyphen user. Just paste that in. The username can have up to 64 characters, valid characters, right? All of that. Provide user access to the AWS Management Console hyphen optional. So if you're providing console access to a person, it's a best practice to manage their access in IAM identity. That's not optional, so it's not like access keys. Okay, so to the AWS Management Console. So I think this is like the console. Okay, I guess so. Specify user and identity center recommended. If you are creating programmatic access through access keys or service-specific credentials for AWS code commit or Amazon key spaces, you can generate them after you create this IAM user. This is what we need. So console access to a person. Yeah, I'm providing console. Well, console in a sense, I'm talking about my terminal. I'm not sure if that means the dashboard or the So I want to create an IAM user. We recommend that you create an IAM users only if you need to enable programmatic access. IAM users only if you need to enable programmatic access through access keys. Specific credentials are different. Okay. I feel like I think this is the one that we need. Okay. Auto-generate password. You can view the password after you create this user. Okay. And then we have enable users. Users must create a new password at next sign-in recommended. So once I do this, I click next. Add user to group. Add user to group. Copy permissions. Attach policies directly. Add user to an existing group or create a new group. Recommend using groups to manage user permissions by job functions. Now over here, it doesn't say anything related to groups. It says attach the Amazon EC2 full access policy for this user, and which grants full permissions to manage EC2 instances and attach policies directly. And which policy we need is, it mentioned it, Amazon EC2 full access policy. Okay, so just copy this and paste it right here. I don't see it. Amazon. Oh yeah, there you go. Amazon EC2 full access policy. Click on this one. AWS managed. Just click on it. It gives me more information about it. Yeah. Okay. It gives you access to EC2, EC2 auto scaling, ELB auto CloudWatch, and all that. So let's just go and click next. Okay, now this is the information. Review and create. Review your choices after you create this user. You can view and download the auto-generated password if enabled. So username is this one. Okay, console password type is auto-generated, and require password reset is yes. Amazon EC2 full access is what our permission is. And another permission summary is IAM user change password. Okay. So let's create that user. Okay. Now we got this sign-in instructions. Download a CSV file. This should download our CSV file, and I'll put in our C drive. So where we're having all our information. So C drive, users. No, I guess it's what is it called? I named a folder something like cloud work or something. So C drive, there should be a folder called cloud work. There you go. So over here, I'm just going to put in Terraform user credentials.csv, save it in here. Other than that, I want to like put this in the terminal. So console sign in URL, it's this one. I would recommend maybe also having it in here. Okay. So in a notepad, I normally save them. Username is this, so they're just copy like that too. Okay. Okay. Okay, so the password is the console password. So I could copy this, I could put it somewhere, like a safeguard or something like that, KeyPass. Those are more secure instead of having it saved in a notepad. But what we're going to be doing is we set up AWS CLI. Now we could set it up. And remember when we were doing configure, it's asking for enter your access key ID and secret access key. You'll also need to set up a default region such as, okay, now that we have all of that, but still, I mean, it's asking me for AWS secret access key ID. What is my AWS access key ID? I don't know what that is. Turn to users list. So yeah, I'll put it somewhere else. So I got the password to it and I put it somewhere. And the problem here is the biggest problem that we're facing is, I'm going to return to user list, download. So we got this user, right? It's not in any kind of user group, right? And password age, okay. And all that's information, ARN creation. But the problem is I don't have the AWS access key ID. I don't know what that is. So where can I find my... Okay, so remember that text file that we saved, ID? Is it this? 2, 12, 4, 8, 2, 4, 6, 8, 10, 12. I think it's this one. 2, 4, 6, 8, 10, and 12. Yeah. So I feel like it's this one maybe. So log into the in the services menu, type IAM in the search, IAM dashboard, go to the users on the left menu, click on your username or create a new one if you haven't already by add user. Under the user details, go to the security tab, the access keys, click create access key if you haven't generated one before. If you have an access key, you'll see it listed here. After creating a new access key, AWS will show you the access key ID and the secret access key. Be sure to save these credentials securely. Download the CSV because you'll only be able to see this secret access key once. Okay, maybe it's in that Terraform user credentials CSV file that we downloaded. But the other thing is that you could go to your in the access key section, click create access key if you haven't. So I'm gonna go to the IAM. I'm going to the user. I'm gonna click on this. Create access key. Okay. Okay. So access key best practices command line interface. You plan to use this access key to enable the AWS CLIs to access your AWS account. I think that looks more. I understand the above recommendation. I want to proceed with the create an access key. So I'm going to create the next and description tag. Describe the purpose of this access key and where it will be used. A good description will help you rotate this access key confidently later. So I'm just saying for practice purposes. Okay. I'll just say for practice purposes. Create access key. Now we got this. Okay, perfect. So this is our access key, what we need, and I could put it right here somewhere. Okay. I got our AWS access key, and we also have our secret access. So access key, and what is this? Secret access. So that's our secret access. Okay. So we got that. You could also download this as well. So you could put in, now you got user access keys, right? Terraform user, this is our user, and then we have access keys. So they're different from credentials. And then we have done. Okay. So now that we have done that, I think now we'll be able to console sign in link. So let's go back, and I believe we'll be able to now enter your access key ID and secret access key. You'll need to set up a default region such as US East 1, which is a free tier eligible. Okay, US East 1, NEWS. So I think it's US East where? Okay, so what I feel like is that maybe it's in the East Coast. Oh no. You know, there's different things, but that's more of the eligible one. Now, what you want to do is you want to paste that in the VS Code. So you got the secret key access key. If you have that, you could just paste it in. So I have it over here, and I'm just gonna paste it in like that. I'll press enter. Now it's asking me for the AWS secret access key. Okay, and yeah. Default region US East 2, US East 1. Default output format none. Okay. Okay, I think we're connected. I don't know what happened, but yeah. Yeah, and don't worry, I'll delete this user later on. So, this is just for practice purposes, and that's why. Okay, so I think we're configured. Um, so you know we got the AWS CLI and we ran AWS and entered our credentials, right? After I create Terraform configuration files in a new directory, Terraform demo, create a new file named main.tf. Now let's go in here, and I'm gonna create a folder here. I'm gonna call it as Terraform under hyphen demo. Okay. Within demo, I'm gonna create a file which is gonna be called main.tf. Okay. So I'm gonna say main.tf. This is our Terraform file. Okay. So this is the code. So we're gonna go through this code one by one. So let's go and paste it here. And I guess VS Code would recommend maybe an extension, but there is an extension that I would recommend downloading for this stuff, and that's called Terraform. It's just gonna give you nice highlighting. This one. Okay. Oh no, I think it was this one. HashiCorp. Yeah, uninstall this one and install this one, the original one. So normally you'd have a verification badge on there. Okay. So it's installing this and recommended based on the files you recently opened. It also detected it, syntax highlighting and auto completion for Terraform. That's exactly what we need. Go back here, and now you can see that's highlighted and everything. Okay, so provider is AWS here, remember, and we have a US East 1, replace with your preferred AWS region. We're done with that. Resource, and within the resource we have a type. So this is an AWS instance, right? So you can see over here, it highlights, it says the resource type. And then the name is the identifier, so it's all the reference name. And this is called example. You could call it anything you want. Now, this is the AMI and an Amazon Linux 2 AMI in US East 1. So we're basically getting a Linux computer. And instance type is a 2t.micro, free tier eligible instance type. It's that. Tags is this one. All right. This is just the name Terraform example instance. Basically, this is just gonna make us our, Linux computer for in the Amazon cloud. That's pretty much it. Um, let's go ahead and run this. So let's go. This file tells Terraform to use the AWS provider and set the region, create an EC2 instance using a specific AMI, Amazon machine image, and instance type. And then we have tagged the instance as Terraform example instance for easier identification. Now we got to initialize the Terraform. Open the terminal and navigate to your directory and run this thing. The command initializes your Terraform workspace, downloads provider plugins, which are like the AWS ones, and prepares it for use. And then it reviews your plan. So basically you use Terraform plan to review everything. And after that, this will show the resources it tends to create. And after that, to create the EC2 instance, we run Terraform apply. And that's pretty much it. That's how simple it could get. So go over here in the terminal. You could go and navigate with you in your folder, which is, for me, it's Terraform demo. I'm going to go inside this folder, and I'm going to write Terraform, and I'm going to write initialize. But before that, let me just show you that this is just those Excel files, right? But now we're in this folder. So if I do initialization, initializes the backend, initializes provider plugins, latest finding latest version of HashiCorp AWS. There you go. Installing HashiCorp AWS. These are the plugins that Terraform will get. After it gets all of that, it might create a folder and some resource. You'll see it. You'll see it. Just let it do its work. Okay, you can see that .terraform folder. In this, it will contain one plugins folder and another one would be, one second, just let it do its job, and one is going to be its providers folder. So here it says over here Terraform has been successfully initialized. You may now begin working with Terraform. Try running Terraform plan to see any changes that are required for your infrastructure. All Terraform commands should now work. So if you go here, we have Terraform, and in here we have the provider, okay? And yeah, and then we also have a terraform.log.hcl, right? And this contains some, because remember the provider that we're using is AWS, and that's why it's telling us that's over here. This file is maintained automatically by Terraform init. Manual edits can be lost in future updates. So now that we have done all of this, what we could do is we could do what we want, and that is essentially, oh yeah. So Terraform provider has this, but we're not gonna go there. We're just gonna go here, which is right here in the main.tf, and I'm gonna open up the terminal again. And what I'm gonna do now is I'm gonna Terraform plan. And my plan is basically to create an EC2 instance. So according to this, main.tf file, um, it's gonna do that for me. So you could see over here we have yeah, you didn't use the -out option to save this plan, so Terraform can't guarantee to take exactly these actions if you want. If you run Terraform apply now. So the thing is, look at this plan that we got. So it's saying Terraform used the selected providers to generate the following execution plan. Now, resource actions are indicated with the following symbols. We're going to create something, correct? Terraform will perform the following actions. And it's saying AWS instance example will be created. Now we have a resource in an AWS instance, and we have an example. Okay. Now this is what, remember, the resource type and then the name, and then we're saying we're creating something AMI. Remember, there's a term, and it's called it was Amazon machine image. Okay, go back. ARN, known after apply. Associate public IP address availability zone, CPU core count, CPU threads per count. All of this is included in this EC2 instance. CPU core count, known after apply. So look how awesome that is. We have availability zone, CPU core count. We'll have disable API stop, disable API termination, EBS optimized, get password data, host ID, all of that stuff, monitoring key name, IPv6, address count, addresses, all of this, and then the tag, which is Terraform example instance, tag all, and this is that. It's showing you all of this things that will be created. Look how awesome that is. CPU options, and all that are saying known after apply. When you create that, you hit the apply command, it will create all of this for you with just this line of code that we added. It will create all of this stuff. So plan 1 to add, 0 to change, 0 to destroy. You didn't use the out option. This is the out flag to save this plan. So right now we're not guaranteeing that these actions if you run. So Terraform can't guarantee to take exactly these actions if you run. Okay, so let's go and apply quickly. Let's move on to. So let's apply. Okay. So you can see over here. It's gonna take some time, but yeah. After that, do you want to perform these actions? Terraform will perform these actions described above. Again, it shows you the same exact plan what we did, what we just looked at, and it says only yes will be accepted to approve. So we'll just type in yes. Once we do that, it was enter a value yes, and then creating EC2 instance operation failed. Response error status 400 request API error invalid AMI ID not found. The image ID does not exist. Okay, this image does not exist with AWS instance example on main.tf file. So the reason why this is failing is because that image, Amazon machine image, right? This one, it does not exist there for US East 1. Kind of like maybe it might not be free or something, but you could actually just copy that error, just paste it here, and it will tell you a better solution to this. I don't know, I just clicked on something random, but yeah, if I press send, you're seeing invalid AMI, and what's saying is that means that the Amazon machine image in your specified in your Terraform file isn't available in the region you selected. That's exactly what I said. AMIs are specific to each AWS region, right? So an AMI ID that works in US East 1 may not work in another region. Here's how you can resolve this. Select the correct AMI for your region. Okay. Now, it's not going to tell us AMI for your region. How we're going to check that out is going to give us, go to the EC2 dashboard in your AWS console. In the left sidebar, select AMIs. So it's saying go to your, Go to your EC2 dashboard in your AWS. So you have to go to EC2 Click on the virtual servers in the cloud. After that, in the left sidebar, select AMIs. So if you go in the left sidebar, you see these images, Amazon machine images. So you click on this. After that, set the region to match the one in your Terraform configuration. So we gotta make sure that the region is set to US East 1. EC2 image builder actions, launch it. Select an AMI owned by me. Okay. Amazon machine images. Info, recycle bin, EC2 image builder, actions, instance launch. And then we have settings. Okay. What I'm going to be doing is EC2 image builder. Click on this. What is this? Build and maintain secure images. EC2 image builder. Start with a base image. No, I'm actually thinking it's set the region to match the one in your Terraform configuration. I clicked on AMIs. And after that, set the region to match the one in your Terraform configuration. US East 1. I cannot find the... yeah, my name, owner, visibility, recycle bin, info, actions. I cannot find the... Let me just go and click on US East 1. So let's copy this, paste it here. I'm not sure this is going to work. But I think this is like if you already created some AMIs before. So let's go back to EC2 dashboard. We have nothing running, right? We have one security group. Okay. So what we want to, okay, this is our region. So I got this information here. Zones. Can we go? I don't know. US East 1 is over here. But when I go to AMIs here for owned by me, you can use the filter to view owned by me, private images, public images, or disabled images. Owned by me, private images, public images. Let's look at that. Okay. Some of these images are public. Source. AMI ID. This is a Windows Server 2019. Okay. It's a machine. If you can find the region where it's located. You can see how platform the Windows with a SQL Server Enterprise root device type. So you could see that this is there's a machine and it's live, it's working, it's available. Everything looks good on it. I'm just trying to understand if I could, because I have US East 1, so I'll just, what I could do is enable additional zones. So what I could do, zones, this service is operating normally. Scheduled events, migrate a server. I'll say this is what I get in my EC2 dashboard. Okay, let's see what happens. The region corresponds to the region code US East 1. Based on this, make sure that if the AMI ID was copied from another region, if not, okay, just giving you instructions. If it does not, what I mostly believe is that this AMI does not exist within my certain region, or it's not available, the free tier one, but we did exactly the same commands, and this is how it works. I mean, there's nothing missing. So the AMI ID is specific to US East 1. If the AMI ID was copied from another region, it will not work in US East 1, right? Choose an Amazon Linux 2 AMI, Amazon machine image. This is free tier eligible and is readily available in US East 1. Now, here's how to locate and confirm the correct AMI ID for US 1. What we did was US East North Virginia corresponds to the region code US East 1, which was correct. Now, how do we locate the correct AMI ID for US East 1? Step to get the correct AMI ID for US East 1. Navigate to the EC2 console. We were there. Go to the EC2 dashboard. Select AMIs under the images section in the sidebar. So images section is AMIs, right? Filter for Amazon Linux E2 AMI. Set the region to this, US East North. Filter by public images and type Amazon Linux 2 in the search bar. You can also add free tier eligible as a filter. So basically what we're going to do is we're going to go to the filter, we're going to public images and search for Amazon Linux 2, and nothing comes up. Sorting, okay, it does come, wait. And also, in the search bar, you can also add free tier eligible as a filter. Let me just copy this and add this as well. Whatever pops up should be our free one. Okay, this is an Amazon AMI kernel. It says that this is a Linux environment. It's available. Okay, so what happens is that set the region to US East. How do I just wish I could understand where I could add this region. Public, build clear filters, launch instance actions, recycle info. Okay, recycle image filter, launch instance from AMI. I don't see name, source ID, owner, visibility, status, creation date, platform, root device, block device, virtualization, and deprecation date. I don't see the region, honestly, but what I'm feeling like is maybe it's this one. Okay. So what we have is copy the AMI ID. Locate the Amazon Linux 2 AMI, typically starting with the AMI and following by a unique identifier. Copy the AMI ID from the search results. There, it's this one. Okay. Let's go and paste it right here. Now, update main.tf with the corrected AMI. That's it. Replace the existing AMI in your Terraform configuration with a new one. Rerun the Terraform. Save the changes to main.tf. So we're just gonna Terraform plan and Terraform apply. So let's go and let's do that one more time. Remember, if it doesn't go through, I mean, we did almost everything the same. So Terraform plan, and after that we're gonna do Terraform apply. Okay, Terraform plan is done. Let's do Terraform apply. Same stuff, remember, nothing changed. Instance type, now you can see over here, is a t2.micro. And we're going to say yes. And AWS instance.example. AWS instance.example is creating. Still creating. And apply complete. Resource 1 added. So we got it created successfully. That's awesome. How can we check it out? We go to our dashboard and we'll see that it should be created within our instances. And you can see over here, we created an instance. US East 1, free instance, and it's a Linux environment. It's amazing. Now if you want to destroy this instance, right, what I would say is Terraform destroy it. And this should completely remove the instance from existence. It was just for practice sake. AWS instance example refreshing state, and there's no way to undo. It's gonna say like this. Look, remember all the changes that we did? We're gonna from true to null, null, and it's gonna say null, null, false, false, all of that, right? It's gonna remove everything. That's the beauty of Terraform. Like how awesome. Or if we didn't have Terraform, we're gonna have to click everything, and now it's gonna set everything from default to null. It's gonna put them values down, so volume size and all that stuff. Root block, device. Okay, I'm gonna press yes. So this will destroy the instance, Elastic Compute instance, which is the virtual machine. All right, and still destroying. You can see it 8449. This is the ID 8449 over here. But once it's like destroyed, it should be gone from the dashboard as well. And now look, it's just one I created. I could create multiple and so many others with this code file. ACL. Basically, this is called HashiCorp Configuration Language, and it's the extension for it's TF. But then you could actually scale this, and then you could do so much with it. So yeah, so it's still destroying. It's taking some time. I just created it, and so destroying it so quickly is destroy complete. It took a little bit of time, but you can see now refreshing the page. But look how awesome this instance ID was here. I think it's 84 in 9A. 1 minute. 84. No, it's not matching the AMI Amazon machine image, but it's some other instance ID. But it has a unique ID. But when I refresh this, it should be gone because I deleted it. So let's see. Awesome. No, 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 no. Okay. Okay, I'll tell you what happened. Instance type is terminated, so that's good. And it was available before, and now it's terminated. It would be gone forever. This is just a log right now, and later on you'll see that it's gonna be gone. So yeah. So basically that's Terraform, and I just leave whatever it is. Let's go to the next part. To the the tutorial. We went through Terraform. That's good. Um, there's this thing called AWS Cloud Practitioner. So if I go to LinkedIn and AWS Cloud Practitioner certification, right? It's this one. I would recommend applying for this one. It's a nice, 90-minute, and it has 65 questions, either multiple choice or multiple response, and it's a very good exam to take, and you're gonna basically get the yeah. So 1 second, let me see. Yeah, so this is basically my friend. Where we're gonna be. I have a person. If I could find the person here. And that guy provided some resources. Find it, come on. Yeah. So this is like a nice link where you go learn. So it's a Amazon AWS Certified Cloud Practitioner exam practice questions. And you can see over here 1 out of 99. So single topic. Now you can see over here. It's like a company is planning to run a global marketing application in the AWS cloud. Okay. Now the application will feature video that can be viewed by users. The company must ensure that all users can view these videos with low latency, right? We don't want high latency because that makes video processing slow. Now, which AWS service should this company use to meet this requirement? what do we need so that the company is planning to run a global marketing application in the, okay, so what is it? Do we need a CloudFront? Do we need an Elastic Load Balancing? Do we need Amazon Kinesis video streams, or do we need AWS auto scaling, right? So you maybe the video stream looks good, but for me, let's see if this load balancing is basically when you need like multiple servers, right? So let's reveal the solution, and it says CloudFront, okay? And that's the reason or the answer for it. After that, we have which pillar of the AWS well-architected framework refers to the ability of a system to recover from infrastructure or service disruptions and dynamically acquire computing resources to meet demand. Okay, so what is this? Like, which pillar of the AWS well architecture? Which pillar of the AWS well architected framework? So you understand the first one is basically Amazon CloudFront, right? We could use this for, what is it called? For video streaming, right? If you want to run a global marketing application, okay? And the key feature was that we wanted low latency. So Amazon CloudFront does the job. After that, we have which pillar of the AWS well architecture. So there's like pillars. So AWS well architected framework, okay? Refers to the ability of a system to recover from infrastructure or service disruptions and dynamically acquire computing resources to meet demand. So this is what it's saying. It's saying which which pillar of the AWS well-architected framework refers to the ability of a system. I mean, let's try to do this with the audience if there's any. But yeah, I'll if you have any like answer, if you know it, put it in the chat, and then we'll see if we're getting it right or we're getting it wrong, right? So which pillar of the AWS well-architected framework refers to the ability of a system to recover from infrastructure or service disruptions and dynamically acquire computing resources to meet demand? So basically what it says is, what is that pillar that when in that AWS well-architected framework, which allows us to recover from infrastructure or service disruptions, right? And dynamically acquire computing resources to meet demand. So what is it? Is it security, reliability, performance efficiency, or cost optimization? For me, I feel like it's not security. It's not going to be. It could be reliability because it's backup. Performance efficiency, I think maybe, but cost optimization, no. So it's kind of be reliability probably. So which of the following are benefits of migrating to the AWS cloud? Is it operational resilience? Is it discounts for Amazon products on Amazon.com? Is it business agility? Is it business excellence? Is it increased staff retention? For me, I think it's like operational is resilience, but let's see. Okay. Okay, so this one I'm gonna ask. So if there's anyone in the chat, we could review it. So awesome, thanks Golem. Thanks for letting me know about your backend journey. That's great. But if there's anyone viewing it, you could add in your response here, and then we could talk about it. So a company is planning to replace its physical or on-premises compute servers with AWS serverless compute services. The company wants to be able to take advantage of advanced technologies quickly after the migration. So which pillar of the AWS well-architected framework does this plan represent? So let's try to do at least 15, and then we'll see from there, right? So a company is planning to replace its physical on-premises compute servers. Some people like prefer on-premise. So a company is trying to replace its physical on-premises compute servers with AWS serverless compute services. Okay? The company wants to be able to take advantage of advanced technologies quickly after the migration. Which pillar of the AWS well-architected framework does this plan represent? Well, we want to shift from on-premise to Amazon serverless compute. So what is it? Is it security? Is it performance efficiency? Is it operational excellence? Or is it reliability? I feel like it's operational excellence, but let's see. It's performance efficiency. Come on. The reason why it should be performance efficiency. Why? Because like um you're changing it from premise to the serverless cloud. It's always going to be better because you don't have to worry about the infrastructure at all. Amazon does that for you. You just pay money. That's it. So that's why performance efficiency is the most appropriate response there. A large company has multiple departments. Okay. Now each department has its own AWS account. Wow. Each department has purchased Amazon EC2 reserved instances. Okay. Some departments do not use all of the reserved instances that they purchased, and other departments need more reserved instances than they purchased. The company needs to manage the AWS accounts for all the departments so that the departments can share the reserved instances. Which AWS service or tool should this company use to meet these requirements? So this is a very nice phenomenon where there's a gigantic company and there are so many departments, right? Now, each department within that company uses Amazon, has its own Amazon account, all right? And each department has purchased Amazon EC2 reserved instances. So each one has a Amazon reserved instances, right? They have, but now some departments don't use all their reserved instances, while others need more than what's already purchased. So what can we do to which AWS service or tool should the company use to meet this, resolve this issue? Is it like an AWS Systems Manager? Is it like a Cost Explorer? Is it AWS Trusted Advisor or AWS Organizations? What I feel like is maybe a Systems Manager. Let's see. No, it's AWS Organizations. So AWS Organizations will help you, get this through. And before all of this out, let me just verify if these answers are all actually correct or not. So you could just copy them and just say over here, just tell me the answers to each of these MCQs. Okay. Oh, no. And so paste it in, send. Okay, so you could see over here, the first one was Amazon CloudFront. We were correct. Reliability was the second one. I believe so. It was reliability. If we go back here. So the first one was Amazon CloudFront. Second one was reliability. Which pillar of the refers to the ability of a system to recover? Yeah. After that, it was operational resilience and business agility. So both ones. Okay. After that, it was performance efficiency, which is, yeah. So it's performance efficiency because when the company is trying to replace its physical on-prem, yeah. And then the last one was AWS organizations. And I guess so far everything is correct. All right, so let's try to go till 6:15. So which component of the AWS global infrastructure is made up of one of the more discrete data centers that have redundant power, networking, and connectivity? So, it's asking us which component of the AWS global infrastructure is made up of one or more discrete data centers that have redundant power, networking, and connectivity. Okay. So which component of the AWS global infrastructure is made up of one or more discrete data centers that have redundant power, networking, and connectivity. Anyone in the chats, if they have an answer or something? Uh, so yeah, which component of the AWS global infrastructure is made up of one or more discrete data centers? It's saying which component of the AWS global infrastructure. Okay, so AWS global infrastructure is like an entire thing. Global. So basically, it's saying which component of the AWS global infrastructure is of made up of one or more discrete data centers that have redundant power networking. Is made up of one or more, okay, one or more discrete data centers that have redundant power networking and connectivity. Component of the AWS global infrastructure. Mm, that have redundant power. Okay. Okay. Yeah, it's asking for which place in the AWS global infrastructure has like one or more discrete data centers that have redundant power, networking, and connectivity. So, um, I think it's AWS region, but let's see. No, availability zone. So, which component of the AWS global infrastructure is made up of one or more discrete data centers and have redundant power, networking, and connectivity? It's what is it called? Availability zone. Okay. Which duties are the responsibility of a company that is using AWS Lambda? Choose two. Okay, it has two over here. Oh, that's why it said two. Got it. I didn't read that. So operational resilience and business agility, which are the following benefits of migrating. Okay, which duties are the responsibility of a company that is using AWS Lambda? So what is AWS Lambda? Any idea? So basically, AWS Lambda is a serverless function as a service provided by Amazon as part of the Amazon Web Services. It is designed to enable developers to run code without provisioning or managing servers. It executes code in response to events and automatically manages the computing resources required by that code. It's an event-driven serverless function as a service provided by Amazon. So it allows you to run code, right, without provisioning infrastructure. And the question is like, what are the duties of the responsibility of a company that is using AWS Lambda? The company should be security inside of code. Security inside of code. I think that's the first one. Selection of CPU resources, patching of operating system, writing and updating of code, security and underlying infrastructure. I feel like, yeah, the first one and writing and updating of code. Basically, you should be very careful because you have your own security stuff inside of that. So which AWS services or features provide disaster recovery solutions for Amazon EC2 instances? Okay. So it's asking which AWS services or features provide disaster recovery solutions for Amazon EC2 instances. And which AWS services or features provide disaster recovery solutions for Amazon EC2 instances? Disaster recovery solutions. Okay, which features? Yeah, so there's like features within the Elastic Compute instance. Which ones are there? So we have reserved instances, 2Y, EC2, Amazon Machine Images, AMIs, Amazon Elastic Bookstore, Block Store, EBS, Snapshot, AWS Shield, Amazon Guard, Duty. So what I feel like is maybe we were talking about Amazon Machine Images, but let's see what is it. Yeah, Amazon Machine Images and Amazon Elastic Block Store. So these are like recovery solutions, disaster recovery solutions for Amazon EC2 instances. We could create different machine images, and we could also have Amazon Elastic Block Store snapshots. A company is migrating to the AWS cloud instead of running its infrastructure on premises. Which of the following are advantages of this migration? Well, the first thing is that ability to deploy globally in minutes. And the second one is elimination of the cost of IT staff members, the redundancy of default for all compute services, increased global reach, and agility. I feel like this one, the need to perform security auditing. Well, you got these two, right? Now, over here we have a user is comparing purchase options for an application that runs in Amazon EC2 and Amazon RDS. Now, what is an Amazon RDS? I heard that before too. Amazon RDS. So it's a relational database service. It's a cloud-based service that allows users to set up, manage, and scale relational databases. RDS is part of the Amazon Web Services and offers a variety of benefits and includes cost efficiency, scalability, replication, automated backups, automated patching, flexibility. Users can maintain their databases, high performance, reliability, and security. RDS can be a good option for startups because it offers a simple way to create database infrastructure on the cloud. That's really nice. I mean, you could use that Amazon relational database service. So, I mean, come on. The world is going on the cloud and people want this. And I feel like this is awesome, actually. I really feel like this is awesome. Mm. Just like a curiosity question, like how much of the internet is on the cloud? Right? How much of is on AWS? Let's see on it's that's 50% share. So Amazon Web Services is the leading cloud computing service provider that and runs a large portion of the internet with an estimated of 31 to 50.1% market share. That's insane. AWS is the most popular cloud infrastructure service provider, controlling 31% of the market. AWS, Microsoft, Azure, and Google Cloud account for 66% of total spend in the cloud infrastructure services market. So combined, they have 66%, and you could see how much of the internet is on the cloud in general. Like Amazon just started earlier, and that's why they have a big advantage, and that's why you could see it's a corporate giant. The amount of data stored in the cloud is increasing, and more of the internet is being moved to the cloud. Corporate data, around 60% of corporate data is stored in the cloud, and more than half of companies store business records in the public cloud. World data, cybersecurity ventures predict that 50% of the world's data will be stored in the cloud by 2025, up from 25% in 2015. So that's insane, actually. Okay, just insane figures. So it's saying a user is comparing purchase options for an application that runs in EC2 and RDS. So a user is comparing purchase options for an application that runs an Amazon compute storage, right? An Amazon Elastic Compute, not a storage, but an Amazon Elastic Compute machine and a Amazon remote relational database service. So relational database service, the application cannot sustain any interruption. The application experiences a predictable amount of usage, including some seasonal spikes that last only a few weeks at a time. It is not possible to modify the application. Which purchase option meets these requirements most cost effectively? Because we have to find something that's the best for this person. Because this application has to run all the time. It requires an EC2 and an RDS, relational database service, and also an elastic compute instance. So what is the best way? And also has some seasonal spikes, and it's not possible to modify the application. So review the AWS marketplace and buy partial upfront reserved instances to cover the predicted and seasonal load. Buy reserved instances for the predicted amount of usage throughout the year. Allow any seasonal usage to run on spot instances. Buy reserved instances for the predicted amount of usage throughout the year. Allow any seasonal usage to run at an on-demand rate. Buy reserved instances to cover all potential usages and results from the seasonal usage. Okay, so the clear goal I think is buying reserved instances, right? Reserved instances will allow you for this, seasonal load that you get. Maybe it's in a holiday that people use this application a lot. So review the AWS market and buy partial upfront reserve instances to cover the predicted and seasonal. Now the partial upfront reserve, but buy it beforehand, I think is better. Buy reserved instances for the predicted amount, or maybe partial upfront. That's because you're saving money. And this one is saying predicted amount of uses throughout the year. So buy reserved instances for the predicted amount of uses throughout the year. Allow any seasonal usage to run at on-spot instance. On demand. Well, I think this one also, like, you have an on demand, like when the demand is there, then you want to use it, right? I think this is like more of like a risk because you're using a partial upfront reserved instance. And then what if you need more than the partial amount, right? So having predicted amount of usage, get a predicted amount and buy that much reserve, and allow any seasonal usage to run at an on-demand rate. So whenever there's a demand, you just run it based on it. So okay, there's just 10. Unfortunately, there's just 10 over here. So we might need more. Let's go back. So let me just create some questions and I'll teach you this other trick because now we don't have more questions. So I'm gonna go here. Now tell me for this, and then paste that in. Press send. Okay, so we had the first one was Amazon CloudFront, then the reliability and operational resilience and business agility, and then we have performance efficiency, AWS organizations, availability zone. Go back if you remember it. Performance efficiency, a company is planning to replace its physical on-premises compute services with AWS serverless compute services. The company wants to be able to take advantage of the advantages. Advanced technologies quickly after the migration. Which pillar of the AWS well-architected framework does this plan? The performance efficiency. A large company has multiple departments. Each department has its own AWS account. Each department has purchased Amazon each virtual, and then it's saying which AWS service or tool should the company use to meet these requirements, and it's saying AWS organizations, which basically allows the company to manage the AWS accounts for all the departments in the company and to share the reserved instances, right? Which component of the AWS global infrastructure is made up of one or more discrete data centers that have redundant power networking and connectivity? And that's basically availability zone. Okay, and then we have security inside of code and writing and updating of code. Yeah, I remember that one. And then we have EC2, Amazon Machine Images, and Amazon Elastic Block Store. Amazon Elastic Block Store snapshots. So this is for like backups. So it's saying which AWS service or failure features would provide disaster recovery solutions for EC2 instances. And then we have increased global reach and agility and deploying minutes. And then we have buy reserved instances for the predicted amount of users throughout the year. Allow any seasonal users to run at an on-demand rate. Okay. Now prepare more questions for the AWS Cloud Practitioner. P-I-T-I-O-N-E-R. can come in the exam. So I'm just writing, you know, not that even good English. And this is gonna give you some more questions and you can learn more about it. So yeah, there's 10 more questions it gives you. We're gonna look at 5 and then we're gonna get a break and then we might continue later on. But yeah, what are cloud concepts? Question 1, cloud concept. Which of the following are characteristics of cloud computing? So here's a set of practice questions that cover essential concepts of the AWS Certified Cloud Practitioner exam. These questions address various domains, including cloud concepts, security, technology, and billing and pricing. These questions address various domains, including cloud concepts, security, technology, and billing. So what is this? Which of the following are characteristics of cloud computing? On-demand, self-service. Choose 2. On-demand, self-service. I think that's the first option, A. Oh, okay. So which of the following are characteristics of cloud computing? What is characteristics of cloud? So it's on-demand, self-service, on-demand, and then we have inflexible resource provisioning, and then we have rapid elasticity, and then we have a limited access to resources. Well, it's not limited, okay? It's not D. It's not on-demand self. I mean, 1 minute, on-demand self. I mean, I think it is A. It's not inflexible. It's flexible. Okay, inflexible means it's not flexible. So you could provision, or you could use this, utilize or get resources. So it's flexible. It's a rapid elasticity, and it's on-demand self-service. A and C. At AWS services, which AWS service is primarily used for object storage? So when you want to store objects, I would say this is the relational database system, and for object, this is for like data, right? Database management system. Whereas an S3 bucket is for object storage. So Amazon S3. Security, which AWS service provides centralized management of security policies across multiple AWS accounts? So which AWS service provides centralized management of security policies across multiple AWS accounts? Well, I think it was like the Amazon organizations, right? Because it allows you to do all of that. So that's nice. Pricing and billing. Which AWS pricing model allows you to pay only for the resources you consume? I like this, and I feel like it's reserved instances, on-demand instances. There you go. Savings plans and spot instances. Well, it's on-demand instances. AWS global infrastructure. So what is the availability zone? What is an availability zone? A global network of edge locations. A physical location with multiple discrete data centers. I feel like this one looks like it. A physical location with multiple discrete data centers. And discrete meaning like 1, 0, right? One data center, two data. A region that consists of several availability zones. Uh, Now we have a network of servers that provides low latency access. No. What is an availability zone? It's basically a location with multiple discrete data centers. That's where what an availability zone is. What is compliance? Which AWS service helps to meet compliance requirements by enabling you to audit and monitor? Audit basically means like inspect or examine and monitor user activity. What AWS service allows to meet? So which AWS service helps to meet compliance requirements by enabling you to inspect and monitor user activity? And I feel like there's got to be a CloudTrail tool, which is there's one AWS CloudTrail. It allows you to inspect, examine user activity. So architecture, which pillar of the AWS well-architected framework? Again, this comes a lot. Well-architected framework uh, focuses on ensuring that systems can recover from failures. So which one is that it could recover from? And I feel like it's reliability, because like it's always going to be reliable. Technology, what is the purpose? And then there's other like pillars like security, performance efficiency, and then we have cost optimization. technology. What is the purpose of Amazon EC2 auto scaling? Um, so auto scaling allows you to like scale as your need requires. So let's say to manage DNS records, no. To automatically adjust the number of EC2 instances and response to demand. This looks more useful. To optimize the cost of an EC2 instance. To provide a content delivery network. See, no, we don't need a CDN. So basically, to automatically adjust the number of EC2 instances in response to demand, right? So we have cloud adoption. Which of the following are common benefits of cloud computing? Okay. So what is the like benefit of cloud computing in general? Like increase IT maintenance costs? No, it's not gonna increase your maintenance IT cost. Global reach. This is one. Increase global reach, reduce time to market, and decreased operational flexibility. Well, it's not decreasing operational flexibility; it's increasing the flexibility. So it's basically reducing your time to market because it's faster, and so it's BNC. Now, AWS management tools. Which AWS service allows you to manage and monitor AWS resources in one place? Which AWS service allows you to manage and monitor AWS resources? All of those resources you can manage in one single place. Which management tool? So I feel like it's the management console. Basically, the main console, what you were looking at when we were, using that practical. So basically, was that it? Now, additional study tips is that review the AWS well-architected framework, understand its pillars and how they relate to design decisions, familiarize yourself with AWS services, know the purpose and basic core functionality, including such as, know the purpose and basic core functionality of core services such as S3, which is, the bucket, Elastic Compute Instance, relational database system, and Lambda, which is used for code, right? For writing code, function-based service. Understand security best practices. This is S3 allows you to store objects, right? Understand security best practices. Get familiar with identity and access management. Okay. Security policies and compliance aspects. Explore pricing models. Understand the differences between on-demand, reserved, and spot latent instances, and know how AWS pricing works. Feel free to ask more questions or any specific topics you'd like to cover. So, explain all of this now, and then provide more relevant MCUs related to the cloud, AWS cloud practitioner exam, Practitioner exam, foundational. Okay. Okay, so it's gonna give us more, but what we're gonna be doing is, let me just look at the chat. So I'm just gonna make sure that I'm gonna take in a break, so I'm gonna come back after some time. Just one second.
What's wrong with it?
So I'll say, yeah, give me all those questions. He didn't reply back. Yeah, so I'm back. If there's any chat or anything, you can leave it down. I'm trying to. I saw that there's the thumbnail issue, so just going to update the thumbnail. Mhm. Change. No, no, it requires me to like get a thumbnail, unfortunately. So Terraform thumbnail or something. I don't know if am I able to use this YouTube. Mhm. Yeah, so okay, you can see I'm back. So let's go over the final part. We're just gonna be understanding AWS well-architected framework. So the AWS well-architected framework helps architects build secure, high-performing, resilient, and efficient infrastructure for applications. It consists of 5 pillars. We have operational So what is it called? The AWS well-architected framework. So the AWS well-architected um, framework, right? So it has 5 pillars. We know that. So we'd have operational excellence, operational excellence, right? What is operational excellence? And then we have security, reliability, we have performance efficiency, and then we have cost optimization. So focuses on operations in the cloud. The AWS well-architected framework helps architects build secure, high-performing, resilient, and efficient infrastructure for operations. It consists of 5 pillars. We have operational excellence, focuses on operations in the cloud, including monitoring, incident response, and evolving procedures. Design design decisions could prioritize automation, continuous improvement, and process management. We have security. Let's just do this really quickly, bro. So what is the AWS well-architected framework? The AWS well-architected framework helps architects build secure, high-performing, resilient, and efficient infrastructure for applications. It consists of 5 pillars. And what is it? The operational excellence, security, reliability, performance, efficiency, and cost optimization. The first one is operational excellence, and it says focuses on operations in the cloud, including monitoring, incident reporting, and evolving procedures. Design decisions should prioritize automation, continuous improvement, and process management. And then we have security. Now, emphasizes protecting data and systems, managing identity and access, and responding to security incidents. And then we have design decisions must include security at every layer, ensuring compliance and risk management. After that, we have reliability, which is basically ensures a workload can perform its intended function correctly and consistently. It involves recovery from failures and the ability to scale. Design decisions should focus on redundancy, automated recovery, and monitoring. After that, we have performance efficiency involves using IT and computing resources efficiently. It encourages adaptive scaling and optimizing secure resource usage. Um, Design decisions should account for using the latest technologies and methodologies. So what is performance efficiency? It basically involves using IT and computing resources efficiently. Encourages adaptive scaling and optimizing resource usage. What is code optimization? Focuses on avoiding unnecessary costs and optimizing the use of resources. Involves using IT and computing resources efficiently. Involves adaptive scaling and optimizing resource usage. Uh, should account for using the latest technologies and methodologies. Cost optimization is basically like focuses on avoiding unnecessary costs and optimizing the use of resources. Design decisions should be made based on cost-effective resource allocation and scaling. What is performance efficiency? We already know that it involves using IT and computing resources efficiently. It encourages adaptive scaling and optimizing resource usage. Design decisions should account for using the latest technologies and methodologies. Cost optimization focuses on avoiding unnecessary costs and optimizing the use of resources. Design decisions should be made based on the cost-effective resource allocation and scaling. Familiarity with the AWS service. Now, what is it? Understanding core AWS services is essential for effective cloud management. Here's a brief overview of key services. So I think you understood the cost optimization, focusing on avoiding unnecessary costs and optimizing the use of resources. Design decisions should be made based on cost-effective resource allocation and scaling. You always wanted a cost-effective solution, no matter what. Adaptive scaling and optimizing resource. Design decisions should account for using those. Okay. Okay, we got all of that. Now let's familiarize ourselves with the AWS services. Understanding the core AWS services is essential for effective cloud management. Here's a brief overview of key services. So what are the different services? One is Amazon S3, which is simple storage service. Second is Amazon EC2, which is Elastic Compute Cloud. Sorry, it's called Elastic Compute Cloud. And the third one is basically a relational database system or relational database service. My bad for that. And then the last one is AWS Lambda. So what is the difference between all these? What is an S3? A simple storage service, object storage service designed to store and retrieve any amount of data at any time. Use cases include data backup, archival, and web hosting. So this is called a simple storage service, object storage service designed to store and retrieve any amount of data at any simple storage service. And what is EC2? Elastic Compute Cloud provides resizable compute capacity in the cloud. Use cases including hosting applications, web services, and batch processing. What is RDS, Relational Database Service? So basically, managed relational database service that supports several database engines like MySQL, PostgreSQL. Okay, use cases including managing databases without the overhead of hardware provisioning and database maintenance. What is AWS Lambda? We talked about this. It's a serverless compute service that runs code in response to events without provisioning servers, right? Use cases include running back-end processes. We already wrote here. It's an event-driven serverless function as a service provided by Amazon. It's an event-driven. So basically, serverless compute service that runs code in response to events without provisioning servers. Use cases include running back-end processes, triggering events from other AWS services, and responding to HTTP requests via API gateway. So it's basically a computer service that runs code in response to events without provisioning servers. Supplying servers. Use cases include running backend processes, triggering events from other AWS services, and responding to HTTP requests via API gateway. Understanding security best practices. Security is a critical aspect of cloud infrastructure. Key elements include the identity and access management, IAM, security policies, and compliance. So let's see what that is. So it allows you to manage user access to AWS resources securely. Best practices include implementing the principle of least privilege, enabling MFA, what we didn't do, multi-factor authentication, and regularly reviewing permissions. Okay, least privilege means you have to make sure that they only give them only those the access that they only need. Security policies. Define permissions and access control for users and services. Security policies include define permissions and access controls for users and services. Important to regularly audit and update policies to align with the compliance requirements. So what is security policies? They're basically define permissions and access controls for users and services. Important to regularly audit, examine, and update policies to align with compliance requirements. Okay. What is a compliance? Ensuring that your architecture meets legal, regularity, and policy requirements. Use AWS compliance programs to guide your design operations. Pricing models. Now, there's different understanding. AWS pricing models helps manage costs effectively. Key models include on-demand instances, reserved instances, spot instances. So on-demand instances pay for compute capacity by the hour or second with no long-term contracts. Best for unpredictable workloads that it cannot be interrupted. So pay for compute capacity by the hour or second. Whereas for on demand, basically like for an hour or two or how many time you need. Reserved instances like reserved capacity for a 1 or 3 year term, providing a significant discount compared to on-demand pricing because you basically reserve something. best for steady state workloads. And then we have spot instances. Purchase unused, easy to elastic compute cloud capacity at potentially lower cost, but instances can be terminated by AWS when the capacity is needed. Uh, Ideal for flexible, interruption tolerant workloads. Purchase unused, easy to capacity at potentially lower cost, but instances can be terminated by AWS when the capacity is needed. Now we have additional relevant MCQs. So we have AWS well-architected framework, and it says which pillar of the AWS well-architected framework is focused on ensuring a system can recover from failures. Well, we know that it's reliability, so it's that. What is Amazon S3 primarily used for? It's used for storing object storage, so that's there. AWS security. Which AWS service allows you to manage access to AWS services and resources securely? AWS service. Which AWS service allows you to manage access to AWS services and resources securely? Which AWS service allows you to manage access to, yeah, basically which AWS service allows you to manage access to AWS services and resources securely. It's like a service that's provided by, Amazon. So AWS IAM, what is it, CloudWatch, or is it RDS? It's basically IAM, Identity and Access Management. Services and resources, yeah. AWS pricing. So which pricing model is best for a workload with a predictable usage pattern? So predictable usage pattern, I would say it's a reserved instance, right? AWS service. Which AWS service can be used to run code in response to events without managing servers? Without managing servers, you already know it's the Lambda, AWS Lambda. Then it's over here, compliance. Which AWS service provides a history of AWS API calls for your account? History of API calls for your account. I heard that was CloudTrail API calls. Yeah. Cost optimization. Which of the following is a key strategy for cost optimization in AWS? Use on-demand instances for all workloads. Enable auto scaling to match demand. There you go. Match demand. Provision resources for peak load only. Avoid using reserve. They basically enable auto scaling to match demand. Performance efficiency. Which pillar of the AWS well-architected framework emphasizes using computing resources efficiently? It's basically called performance efficiency. AWS global infrastructure. So what is the primary function of an AWS region? What is the main function? Primary function of the AWS region is basically to provide high availability across multiple availability zones. Service manager. Which AWS service can help you monitor your AWS resources and applications? It's basically the CloudWatch. Which AWS service can help you monitor AWS resources? It allows you to monitor them, right? It's CloudWatch. Amazon CloudWatch. Okay, so one thing that I wanted to clarify, it could be like a question from you as well, is that we really don't understand spot instances properly. The purchase you unused EC2 instances at potentially lower cost. But instances can be terminated by AWS when the capacity is needed. Ideally, in uninterruption, interruption tolerant. Is this like? Is this like? I don't get this. Is it like if you if Amazon needs the storage or resource back, they can take it anytime they want. So is it the cheapest plan? Yes, you have the right idea. Here's a cleaner breakdown of spot instances. What are spot unused EC2 instances? Spot instances allow you to use Amazon EC2's unused compute capacity at significantly reduced prices compared to on-demand instances, potentially lower cost because these instances are often sold at a steep discount, sometimes up to 90% lower than on-demand instances. They can be a cost-effective option for certain workloads. So you got on interruption, terminate with notice. AWS can terminate your spot instances when they need the capacity back for on-demand instances, and they need the capacity back for on-demand instances or other higher priority workloads. When this happens, you typically receive a 2-minute warning. Not guaranteed. There's no guarantee that your spot instances will always be available, so they are best suited for workloads that can tolerate interruptions. Flexible and interruption tolerant workloads. Ideal use case: spot instances are best for applications that can be stopped and restarted without significant impact, such as data processing jobs that can be divided into smaller tasks, batch jobs, background processing tasks, applications that have flexible start and end times. Pricing: dynamic pricing. The price of spot instances fluctuates based on supply and demand. You can set a maximum price you're willing to pay, and if the market price exceeds that, your instance may be terminated. Comparison with other pricing models, cheapest options. Spot instances are usually the cheapest option if you can handle the interruptions. However, if your application cannot tolerate interruptions, you might want to consider on-demand instances. Pay for compute capacity by the hour or second without any long-term commitment. And reserved instances commit to using EC2 for a 1 or 3 year term, which offers significant cost savings compared to on-demand instances for predictable workloads. In summary, spot instances are a great way to save costs on compute resources in AWS, specifically if your workloads can handle the potential interruptions. However, for mission-critical applications where downtime isn't acceptable, spot instances are a great way to save costs on compute resources in AWS. Especially if your workloads can handle the potential. However, for mission-critical applications where downtime isn't acceptable. In summary, spot instances are a great way to save costs on compute resources in AWS, especially if your workloads can handle the potential interruptions. However, for mission-critical applications where downtime isn't acceptable, you would likely need to use on-demand or preserved instances instead. Yeah, that was pretty much it with the stream. I'm closing it out now.